All right, so this is a formative breakdown of the formative that we took yesterday. So I'm going to go through it step by step. All right, so the first thing, the first problem that we dealt with, we had beryllium and chlorine. So the first step in any ionic or covalent drawing is we got to draw the Lewis dot structure, okay? So beryllium's Be, and I'm going to find it on the periodic table. It's in group 2, so I know I'm going to have 2 valence electrons, okay? Then I have a chlorine. I'm going to have 7 valence electrons for my chlorine, okay? So looking at this, I know that chlorine needs at least 1 more valence electron, okay? And beryllium needs to get 2 valence electrons. So beryllium's going to do its first move by giving 1 valence electron to the chlorine, okay? Now this chlorine is set and happy because it said it has 8 full valence electrons, okay? However, beryllium still has 1 more valence electron than it needs to give away, okay? So if we added another beryllium here, it would just cause more problems. Okay, if we add another chlorine, okay, all right, that extra beryllium electron now has a place to go, all right? So by adding an extra chlorine, we're able to see that beryllium can give up its final valence electron, okay? So once those are all set, so I'm going to go back here for a second. This chlorine has 8 valence electrons now around it. Beryllium has gotten rid of both of its valence electrons. So every element here has fully done its job, all right? So then this is not the final answer for an ionic bond, all right? So the final answer for an ionic bond, okay, the product, we have to have it with the charges, okay? So beryllium lost 2 valence electrons, so it's going to form a +2 charge, okay? We have 2 chlorines, okay, so I'm going to put a bracket around it. All right, each chlorine only lost 1 valence electron. I had a lot of students telling me that it was -2. It cannot be -2. Since each chlorine only gained 1 valence electron, we have to show that, okay? And then I, of course, have to show that I have 2 chlorines. So I put a 2 in front of here, okay? Some of you were forgetting to show me how many chlorines I had. All right, so this should be the answer that you have for the first problem. Okay, so then answer problem number 2 is potassium and nitrogen. So just like every problem we're going to do, I start it with the Lewis dot diagram. Okay, so I'm going to go ahead and draw my first potassium and my first nitrogen. Okay, and if we notice here, nitrogen has 5 valence electrons, potassium has 1. So when potassium gives up that first valence electron, nitrogen still has to find 2 other things to bond with to become a full and happy 8. So this potassium is good, but our nitrogen most certainly is not, okay? So I'm going to need another potassium. So I draw another potassium. It's going to give up its valence electron to nitrogen, okay? So that potassium is good, but we still have 1 more nitrogen that needs to find a pair, okay? Let me phrase that. We still need 1 more electron, okay? They're not going to pair. We just need 1 more electron, okay? So we draw 1 last potassium. It's going to go ahead in, all right? So now we're going to draw our final product. So I need to draw my potassium with a +1 charge since every individual potassium only lost 1 electron, okay? And then nitrogen with all 8 valence electrons and a -3 charge, okay? A good way to check to see if you have the correct final products, you can write the formula. So nitrogen, potassium was a +3, nitrogen was a -3. For every 3 potassiums, we should have 1 nitrogen, which, if you look at our drawing, that's what we have, okay? If you have any additional questions, please feel free to email me.